All right, so I'm at the homework and practice on page 177. We're going to do just a couple of these together for additional practice so that you guys will excel on your homework. So we're going to do number 2. Let's see, what are the directions? They really don't give us directions. So I guess, all right, a car dealership sells 5 cars per day. The total number of cars C sold over time in days is given by the function C of t is equal to 5t. Complete the table of values for the first 4 days. All right. Common difference is 5. What do the variables represent? Well, your independent variable is the number of days, and your dependent variable is the number of cars that are sold. Reasonable domain and range, well, we're just going to stick with what's actually identified in the graph and not go any in the table and not go any further. So we're going to say that a reasonable domain and range, domain would be 1, 2, 3, 4, so you just put 1, 2, 3, 4. A reasonable range in this situation would be 5, 10, 15, 20. Okay. If you wanted to extend the table, then, the domain and range would be just any positive integer for days and then the corresponding number of cars. All right. Okay, so that was number 2. I kind of almost feel like that was too easy. They really just wanted common difference and what do the variables represent. All right, so let's go ahead and go to number 5. All right. Juan is traveling to visit universities. He notices mile markers along the road. He records the mile markers every 10 minutes. His father is driving at a constant speed, so complete the table. All right, so from 520 to 509, that's a difference of minus 11. From 509 to 498, again, that's a difference of minus 11. So we're going to do minus 11 to complete the table. And then we're also going to find f of 10 by using our lovely little explicit rule. Our f of 1 value is 520. Our common difference is negative 11. All right, so 498 minus 11 is 487. And then 476, 465. I think those are, those are good. All right. So we've completed the table. Now we're going to use the explicit rule. And the phone rings in the middle of class. Okay, so phone call taken care of. Where were we? Explicit rule, f of n is equal to the f of 1 value, 520. And then this time it's going to be minus 11 because it's decreasing by 11 each time. And we're going to do n minus 1. All right, so putting all that together to find f of 10. 520 minus 11, 10 minus 1. Okay, so 10 minus 1 is really 9. 9 times negative 11 is negative 99. So we have 520 minus 99, and that is 421. All right, so that means the mile marker at time interval 10 is 421. All right, I'm now on page 179, and we're looking at number 9. The local wolf population is declining. The graph shows the local wolf population over time in weeks. Find f of 9 and explain what it represents. Okay, so f of 1 is 100. F of 2 is 94. So that's a difference, a drop of 6 from 94 to 88. That's another drop of 6. 88 to 82, that's a drop of 6. Okay, so your common difference is negative 6. Your f of 1 is 100. I'm going to write my explicit rule. And then it says find f of 9 and explain what it represents. Okay, f of 9. Okay, 9 minus 1 is 8. So 6 times 8 is 48, so minus 48. 100 minus 48, so f of 9 is 52, which means after 9 weeks, your wolf population is only 52. So I don't know what's killing them off, but that's not good news. All right, and then 14 we're going to do, and it's on page 180. So seats in a concert hall are arranged in the pattern shown. The number of seats in the rows form an arithmetic sequence. Write a rule for the arithmetic sequence. All right, so row 1 is going to be your f of 1, and there are 6 seats. Okay, let's see. 1, 2, 3, 4, 5, 6. All right, I've added 1, 2, 3 seats. Let's see. Let's make sure that that's the same. 1, 2, 3, 4, 5, 6, plus the 3 from the last one, plus, yep, 3 more. Okay, so the common difference is going to be 3. So the number of seats in the rows form an arithmetic sequence. Write the rule. Okay. So basically, you're just writing an explicit rule. And that's going to be 6 plus 3n minus 1. How many seats are in row 15? So basically you're being asked to find value of the function when n is 15. 6 plus 3, 15 minus 1. So f of 15 is 6 plus 3 times 14. Golly, my phone. Okay, hang on just a second. Okay, so let's try that again. F of 15 is going to be 6 plus 3 times 14. That's going to be 42. 42 plus 6, and that's 48. So in the 15th row, if the pattern stays the same, you're going to have 48 seats. Awesome. All right. That should kind of do it for practice problems and examples. Let me just look through your homework real quickly to see if there's anything that's a potential snag. You're just writing terms in a sequence here. So first term is 1, so you put in a 1 where it says n. Put in a 2 where it says n for the second term to get the second term. Put a 3 where it says n to get the third term in the sequence, etc. I mean, that's basically what you've been doing with functions all along. So that's nothing new. Let's see if there's anything. Explicit and recursive rules. Lots of explicit and recursive rules. And there should be plenty of examples that we've done now to help you guys figure all of this out. So get this finished. You are to finish it on your own and turn it in when you're finished.